So we are on chapter 3. The winning theme music for this unit is Today's Hits. And chapter 3 is all about systems of equations. A system of equations is when you have two or more equations that you are looking at as a group as opposed to at each individual equation. So the solution would be where, if you're looking at a graph, it's where the lines intersect. So an ordered pair that would make both equations true. There are several different types of systems. The first type of system is inconsistent, and that's when the system has no solutions. So think graphically what that might look like if the two lines did not intersect. There's consistent systems, and there's two different types of consistent systems. A consistent system just has a solution, has at least one solution. If the system is independent, it has exactly one solution. So again, start thinking graphically what that might look like if two lines intersected at exactly one point. And then a consistent dependent system has an infinite number of solutions. So maybe think about what that graph looks like. If there's more than one solution, you have two lines, how do we get more than one solution? We'll take a look at that. So we're starting off with two objectives for this unit, for this lesson. I can solve a system of equations using graphs, and I can classify systems and determine the number of solutions. So the first thing we're going to do is classify systems based on the graph, and then we're going to take a look at a process for classifying systems based on their equation. So our first example, we're going to determine if it's consistent or inconsistent. Consistent, remember, has a solution. Inconsistent does not. And then if the system is consistent, we further classify it as dependent, has infinitely number of solutions, or independent, has exactly one solution. And we will tell whether it has one or infinite. All right, so jot down these graphs. Our first graph, we have parallel lines. So thinking about the fact that these two lines do not intersect, this would be an inconsistent system. Or no solution. If it's inconsistent, we are done classifying. Taking a look at B, we've got a blue line and a red line, and they appear to be overlapping. But that means that they do intersect, which would make it a consistent system. And because they intersect at more than one point, this is dependent. So this would have an infinite number of solutions. On our last graph, we have two lines intersecting at one point. They intersect, so it's consistent. There is a solution. There is exactly one solution. They only intersect at one point, so it is independent. And as we talked about, one solution. All right, this next slide has a lot of information, and it is all about how to classify systems based on the equation versus based on the graph. So the first thing that you're going to want to do is put the equations into slope-intercept form. Because once they're in slope-intercept form, you can tell if the lines are intersecting. They have different slopes. They're the same line, they'll have the same equation, or they're parallel. They have the same slope, but different y-intercepts. And then, once they are in slope-intercept form, this system would be consistent if they intersect or are the same. It would be inconsistent if they're parallel. If the system is consistent, we would further classify it as independent. They would have different slopes, or dependent, it's the same line. And I would say we don't need to bother with this last one because parallel lines are inconsistent, so we would not further classify the system. So don't bother writing that down. And then we would be able to tell how many solutions it has based on, again, if they are intersecting lines, they have different slopes, there would be one solution. If it's the exact same line, it would have an infinite number of solutions, consistent, dependent, and then the parallel lines, the same slope, different y-intercepts, would have no solution. That is it. So let's take a look at one example where we classify based on the equations. So the first thing we need to do is rewrite these in slope-intercept form. So I'm going to add 24x to both sides and divide everything by 8. I'm going to do the same thing for this line, subtracting 45y from both sides. Sorry, 45x. And dividing everything by 9. And then we will classify the system. So the fact that these two equations have different slopes, if they have different slopes, that's all we need to see to say that it is consistent. They will intersect. And it is independent because they are not the same line. So they'll only intersect once, and they'll have one solution.